phase diagram. We'll do a phase diagram. Also, one of the important chapter. As you can see, CL3, its phase diagram, will be your test 2, question, and also final exam question. Okay, so for this chapter, we are now going to the 9. Okay, so we'll look at a lot of diagram. So you can, for your next class, or you can download the tutorial question, because all the chart is on the tutorial question. You don't need to, you can apply the graph directly on the tutorial question. Now, before we learn about the diagram, when you mix sugar with water, there's a certain percentage where you keep on adding sugar, no more sugar will be dissolved into the water. Okay, so this is water. And you add sugar inside here. So inside there, sugar will be go inside the thing. There will be a percentage of sugar that can dissolve inside the water. So that one is called solubility limit. Okay, solubility limit. After it reach solubility limit, even though you add more sugar, you will see other sugar inside the solution. Okay, now we plot graph in a chemical understanding. So we have temperature and composition, WT, weight percentage. So you already learned how to calculate the weight percentage in earlier. So this one is on the percentage. So just be careful when you read the composition. Again, this is just an introduction. You will not see sugar and water in your test. You will see metal. You will see metal. So on the left here is sugar and water. So sugar 0% to 100%, and water is 100% to 0%. Okay, and there are few state. State means condition, physical condition. You have liquid, you have solid, and you have gas form. Okay, so very easy. For example, if the condition at left hand side, then the solution will be in liquid form. In all the temperature or all the composition over here, you will see that you will be seeing liquid solution. Okay, but on this side, if the interest point fall on any area, or this area here, you will get solid solution and solid sugar. Okay, this red line is solubility limit, means all the sugar that you have can dissolve into the water or into the water. Okay. Okay, the rest you read now. So the rest you read. So how to use this graph? Basically, it's like your XY graph. You either read from the left, then project, touch the intersection point, move down, or from the Y, you move up and then move to the left and read the data. Okay. So for example, this case, at 20 degrees C temperature, you want to find the solubility of sugar in water, you just project down, it's about 60 something. Okay, about 60 something percent. of water or sugar. Okay. So in this case, or this line, you can say as is in the equilibrium. Okay, so you have three state: gas, liquid, and solid. This is water. You apply for the same as metal, right? So if you want to get this form, a few parameter that you can control with is pressure and temperature. These two, pressure and temperature, will affect the state of the element. Okay, a phrase, we use phrase to describe the physical appearance of that element. So, for example, solid phase, liquid phase, gas phase. Okay. Sometimes the question you will see homogeneous is called single phase. Single phase means only one, right? For example, water, water, sugar, sugar, right? But if you have sugar, water formed together, they will become heterogeneous system. Okay. So this is another phase diagram. We are now in the phase diagram. Phase diagram, this word, phase diagram. Phase diagram, this is water. For water, so pressure and temperature, water can behave in three forms: gas, liquid, and solid. So on this line, all these blue line, they are solubility limit or equilibrium form or equilibrium line. Okay. On the left, as long as the interest point fall on the solid area, then you will see solid. If fall in liquid, then liquid, vapor, then vapor. Okay. There's one interest point here. We call it triple point. Triple point, this point, is where a point where three phases appeared at the same time. This point, this triple point. So on phase diagram, there will be one point for metal also. You will see three phases appeared together. In this case, triple point of a water, it will be around 0 degree and at a pressure of this point. And we call it coaxis, coaxis. Okay, the rest you read. Okay, so this one, you only see one component, which is water. Water. So this is called one component phase diagram. Okay, liquid vapor, liquid solid. Okay, so there are some names to identify. For example, this line on the right, this is called vaporization line. This line is having two sides, is touching liquid and vapor. So this line is called liquid vapor line or vaporization line. Okay, so then this line is solid and liquid. This one, this line here is solid and liquid line. This line, solid and liquid. So you look at your neighbor, left, right, then you give it a name. Okay. Okay. So all this line, because they have two neighbor, so when you change the temperature or the pressure, you will change form, right? Either to the left hand side neighbor or right hand side neighbor. So this one, you can either form into solid or jump into liquid form. Now we go into the liquid, pure iron. Okay. Now pure iron, here you're having a pressure and temperature also. And very directly, all this blue line, they are double phase line. So this line to here is vapor and solid. Okay, vapor, solid. How you know is either liquid or solid. For metal, if you see a name, alpha copper or alpha ferrum or gamma something, that is solid. Okay, you see liquid, liquid lah. Vapor, vapor. If you see a scientific name, then it's a solid phase. For example, this one, delta ferrum is solid phase. Okay, so this one, all this line, you should be able to understand what does it mean. And then this this black line, straight black line, it represents the phase also. So when you have intersection point, for example, the lower point here, this is called triple point because at this point, three phases appear. Three phases appear. What are the three phases? On the left will be vapor. On the right will have two solid. Although this one is solid, but it's a different solid. So it's also one state here, one state here. So one state is gamma, one state is alpha. So this point is triple point. Okay. Now, how the question will ask you? The question will ask you identify triple point on the phase diagram. So you go to the diagram, you read the diagram, and then you see, do you understand the phrases or not? Identify three phrases. For example, this one is one. Then you need to name what are the phrases appeared on this line. So you need to give the coordinate for the triple point. So you say the first triple point appeared at what temperature, what pressure. At the first point, you need to label point 1. The question will ask you to label, either label A, B, C, or 1, 2, 3. So this is 1, you label. Then you in your answer, you say refer to the graph point 1. First triple point will be at 1000 degrees C. Pressure will be so and so. Read from the graph. The three phases are vapor, gamma ferrum, alpha ferrum. Or you just copy alpha ferrum bracket FCC, alpha ferrum bracket BCC. Nothing complex here. Then the second point is here. Second point is here. So second point, you will see three phases also, three state also. You have vapor and what? What are the solid you have? This point. What are the solid you have? Delta ferrum BCC and gamma ferrum FCC. Okay. If you mention alpha, then wrong already. Alpha is at this line, 910 degrees C and below. Another triple point is here. Here you have three phases or three state: vapor, liquid, and delta ferrum. Okay. Okay. You understand? Then you are good. So the rest just elaboration on the line. Just elaboration on the line. Now, for example, at 1 atmosphere, 1 atm, 900 degrees C. So this one, you will see double phase. This line, you will see double phase. Double phase means you have gamma and alpha. Okay, below here is single phase, single phase, single phase, single phase, single phase. Okay, all this area are single phase. Triple point, we already mentioned, right? Then we go into a mathematic model to calculate how many % of liquid or solid inside that particular pressure and temperature. So the mathematics model is called Gibbs phase rules. Gibbs phase rules, all right? By this person, Gibbs phase rules. Actually quite easy. It's just a ratio on the line. Gibbs phase rules the first equation for today. P plus F equal to C plus 2. The 2 here, some equation, later I will show you P plus F equal to C plus 1. We now look at the first one first. Okay, so P is number of phrase, co-axis in the chosen system. F is the degree of freedom. C is the number of component in the system, plus 2. Okay. So let's look at what this one is water. Okay. So we take this phrase diagram to explain the Gibbs rules. Okay. So at triple point here, at triple point, you will see 3 phrases coexist in the equilibrium. Right. Since there is only one component in the system, which only you look at water. In the phrase diagram, you look at water. Because later you will look at binary system. You look at metal plus something. 2 metals mixed together. So this example, you only look at water. So the calculation, P will be 3 at this triple point. C will be 1 because only look at water. So you substitute inside the equation. The freedom will be 0. Means at triple point, no freedom, nothing you can change. Parameter, nothing you can change. You cannot change pressure, you cannot change temperature. At that exact point, only you can find triple point. So this is called 0 degree of freedom. Okay. Next, we consider a point along liquid-solid freezing curve. Can you find where is this line? Where is this liquid-solid line? Liquid is here. Solid is here. So we ask you to find liquid-solid line. This is this one. Okay. In the test, you won't see all this labeling. You will see the phrase, but you won't see the labeling. You won't see triple point. So any point along this line, 2 phrases coexist. So how many freedom along this line? So again, P plus F equal to C plus 2. How many component? 1. Phrases 2. So your F is S will be what? P is 2. C is 1. So F is what? 1. Okay. So F is 1. So it means you have 1 degree of freedoms. What does it mean? Along this line, you can either fix temperature, you play with pressure, or you press, or you fix pressure, you play with temperature. Then it will change phase. Okay. So try to understand this one before you go into a real metal case. Okay. Yes. Yes, it will change from either solid or liquid. So for example, you fix pressure. So fixed pressure, let's say we fix at 760 this pressure. So if we fix this one, we only want freedom, we can play with temperature. So we can move from left hand side to right hand side. So it can be changing. If you change temperature, you will change solid. And then reach this point. This one is 2 phase. Then you reach this point, it become liquid. Okay. Now if you play on this line, if you play on this this one got 2 phase this one. Is the three phrase is there. You cannot choose. 3 phrase coexist at this point. Means that this one ABC. You will see ABC at this one. Yeah, you cannot identify which one, but the three will be there. Understand? Mean at this point, triple point, you will see solid, liquid, and vapor at the same time. But you don't know how many percentage of solid, how many percentage of liquid, how many percentage of vapor. Okay. So this is F equal 1. Means you can play with one of the parameter. So the third one is single phase, which is in the empty space here. So inside single phase, any point, if you go any point here, let's say you just pick liquid lah. So this equation, how you solve? P is what? C is 1. P 1. So your freedom will be? Freedom will be 2. Inside this area, you can play with temperature and pressure. There are so many unknown here. Due to unknown, you can play. Yeah. Yes. Yes. Correct. So just now the double phrase one is you follow along the line. You want to walk along this line, you can only fix one parameter. Fix, then you can change only one parameter. If you want to walk in this area, you can play with 2 parameters. At this triple point, you cannot play with any parameter, fixed already. Okay. Okay. So okay, this one is 2. So if you have binary, this one, if you have a binary phase diagram and the pressure is kept constant, then you cannot use +2. You need to use C +1. This one, just take note. Some of you might confuse when you do revision. When your phase diagram, it mentioned pressure constant, means you look at the phase diagram, something below there, you will say at pressure 10 psi. This is constant. So constant, you cannot use +2, you need to use C +1. Yeah, I'll just take note. So why the previous example we can use C +2? Because pressure is one of the axes here. You can play with pressure. So this one, if you read textbook, some textbook, they don't explain this one. Some textbook, they just give you C +2, C +1. So you might confuse. Yeah. Okay, another one, cooling curve. Cooling curve is like we look at metals. So when you pour from hot liquid metal, you no need to do anything. When you release energy, you will start from liquid, then start to cool down, become solid. So this graph is very direct. If you follow the line along, the maximum temperature that you can have will be the pouring temperature. When you pour, that is the maximum temperature that you have. Then, because of condensation or the radiation effect, then it will start to release energy, temperature will drop. Until one point, you will see some metal particles start to appear. We call freezing temperature. So this line is called cooling line, cooling of liquid. Then you will see B solidification will start. Then here to here, at this temperature, it will hold at this temperature for a certain period of time. So B to C, it will start to have small metals particle, then it will become bigger and bigger. At C, it will stop. Once you have 100% become solid already, but still have hot temperature there. So when it becomes solid, hot, then it will cool down. So here, liquid, then percentage of liquid will drop. 0% liquid here. No, sorry. All the liquid A to B. From B point, solid start to have appeared in the liquid. Then B to C, the percentage of the percent of liquid will become 0. Solid will become 100% here to here, right? So this is solidification begin, B to C, right? Then when you reach C, means 100% solid. B to C, B still have a little bit liquid, right? But you just, what's the difference between AB and BC? AB is all liquid. AB is all liquid. Then B, start from B, you start to see some like chicken pop inside the liquid. So small solid will appear. Then become bigger and bigger. When you reach C, 100% solid, no more liquid. Then start from C to D, 100% solid, but temperature cool down. So these are the state lah. These are the state above time. We don't use this chart in the exam, but you need this one if you conduct material science experiment. You do ironing or you do metal solidification experiment. Then you need to plot temperature versus time. Okay, the rest I already explained. Okay, so this slide, some high-level academic writing, they will call this BC line as a plateau. Mean the temperature maintained, but something happened inside the molten liquid there. Okay, the rest you read, huh? Another one is called metal. This one very direct, huh? If you drop the temperature from 1538 to 900 something, and below 900 something, the phases of metal will change. This is versus time. So it will start from, if you above melting temperature, you will still liquid. So if you fall below melting temperature, 1538, different metal have different melting temperature. So start from melting temperature, you start cooling down. First type of metal will form gamma. Drop again temperature, gamma will change to this one. Delta will change to gamma. Then you drop 900, gamma will change to alpha. Okay. Now because of this temperature change, the color that you see in the real experiment, it will be changed also. It will change from you'll see three different color. You'll see green, you'll see red, you'll see orange color. Okay, we'll start to see phase diagram. But before that, we now start to mix two metal together already. Just now what you see, the graph only one phase, water and pure metal. But now we start to mix two type of metal. it become binary system or binary alloy. So it can be either happen two type of method. You can either do substitution. You substitute the host or solute with solvent. Then or insertation, you fix inside the space there. There are two types where you can form binary system, either substitution or interstation. All right. In this system, only a single type of crystal crust structure called axis, and they are called isomorphosis system. Iso means one or similar or singular. So you want to study about the solid solubility, you need to recall that what you have learned previously called HR rules or Holmes rules. This you already seen this one previously. First, size of atom cannot more than 15%. If you want to do substitution, cannot more than 15% the size. Second, it cannot have any chemical reaction, cannot form compound. How chemical reaction can happen? Because of the electronegativity between the two elements. Third one, crystal structure must same. If crystal structure cannot same, it's not same, then it's like a Lego bricks. You cannot form a similar shape. Then if you cannot form similar shape, there will be a gap between the two elements. So these three, these are the Holmes rules. If sometime this one will appear in the first section of the question, section A, explain what is Holmes rules. What is Holmes rotary solid stability rules? You need to write these three. Right. And number 4, same variance. Four rules. Point number 2 is electronegativity. No appreciate difference is electronegativity between the two elements. Means the tendency to become negative. This one, same variance, is the number of electron outside the orbits will be the same. Right. Okay, now we start to see the important graph for your tests and final exam. We start to see binary system. You look at y-axis and x-axis. If you look at this kind of graph, you only see temperature and WT percentage of something. This one is constant pressure. This graph is constant pressure graph. So if the question asks you to use these rules, don't use this one, use this one. Okay. How to read this graph? You read the caption of the graph. This one, it tell you what percentage of nickel. So the percentage you see on the x-axis, they are nickel. Okay. So here you see copper here, you see nickel here. So the two number when you add, you take nickel plus copper must 100%. So at this point will be 0% nickel, 100% copper. At this point, 10. Here is 10% nickel, 90% copper. And this point, 70% nickel, 30% copper. Okay, how you write if you're answering? Okay, let's say this one is 20%. This one, let's say I put nickel. So this point here is 20% nickel, 80% copper. Mean this line, this line here. Okay. Okay. For example, this line, this first dot line, this is about 45% nickel, 55% copper. This one, 55% nickel, 45% copper. So don't confuse with this one. First, you read phase diagram for metal. You look at the caption first. If the caption mention nickel, the main parameter we focus on is the element. For example, this one, nickel, then you look as nickel. The more you move to the right will be the component. Don't confuse that. Then this one, temperature, we look at Celsius. Okay, how many type of phrases that you can see on the graph here? How many phrases? What you have? Can you name the phrases? Can you name the phrases? Who haven't signed? Please sign your attendance. Chin. Yeah. Chin. How many phrase you have on this graph? On this chart? How many phrase? Two, meh? Okay, what are the two? What are the two? If you see two, what are the two? You say two, ma. So what are the two? I asked you about phrases. Solid is one. What are the solid you have in on this graph? You need to identify the solid name. What are the solid you have? Can see alpha, right? Okay. So alpha is nickel alpha. Is solid. Okay. Then what else? How many phrases? What do you think? How many phrases? Two? Why two? Liquid and solid. What about the middle part? You have three, You have three phrases actually. Liquid, solid, and the one in the middle. Mixture between liquid and solid. Okay, so you have three zone. You can say as three zone. Okay. This blue line represent two phrases line. Can you see? If I look at the lower line here, this lower blue line, what does it represent? Okay, what does it represent? This one, this line, you have two neighbor. One is alpha, liquid, and solid alpha. Left, right. So if you walk on this line, if you walk on this blue line, you actually walking become solid line. This line, at this line, it become equilibrium already. So this line, it means no liquid, but you are becoming solid already. This line, this is a boundary where the metal becomes solid. Below this line, all solid. Okay, so this one, you will see solidus line. Solidus line, it means this, or if you walk on this line, if you walk on this line, you will see two phrases beside you. One on the left is liquid plus alpha. The one on the right is solid alpha. But if you walk on the line, it means you walk on the solidus line, means you only see solid. You will become solid, right? 0% liquid. Okay. Then if you walk on the top line, blue line, you have two neighbors also. One is liquid plus alpha. So this line is called liquidus line. Liquidus line. So you're actually seeing liquid if you look at this line, but you start to see solid chicken pox start to appear on your right hand side. Okay. So there are three zones. There are three zones. So liquid plus alpha, and solid alpha. Okay. So if I pick any point, you should able to see explain what actually happened on the metals. So okay, so if I pick a reason here, all are solid. You pick on the top reason is all liquid. Pick middle is alpha, liquid plus alpha. So again, if I walk on the blue line, if the question asks you anything, any point that touch the blue line, it means this blue line, it depends on the temperature and percentage of weight. So if you walk on the blue line, it will tell you how many percent of liquid you have, 100% alpha you have, and so on. Okay. So on the below here, it is 1084. What does it mean? 1084. If your temperature reach 1084, 0% nickel, 100% copper. What do you think? This point will tell you. This point. This point, no nickel. You have 100% copper. Mean this one is you can say is the melting point of copper. Okay, 0% of that one. Okay. Then this point is 100% of nickel. You can say this one is melting temperature of nickel. It's a point where liquid start to form solid lah. You can say like it's a melting temperature there. Okay. Okay. So all this dot you should able to see. So for example, we maintain at 1300 Celsius. You draw a line parallel 1300 Celsius parallel to the right. You will touch two dots here. One on the upper blue line, one on the lower blue line. This one, or top of the blue line, you expand down, you get 45% of nickel. Means at 1300 degrees C, if it's on the liquidus line, you will start to see 45% nickel appeared on this temperature, and 55% of copper at this temperature. Okay, you extend further, same temperature, 1300 degrees C, you expand down, you will see about 58% of nickel, 42% of copper at this temperature. Okay, so it depends on percentage of nickel and copper you have at this temperature. Then the question will ask you any point along this line. Okay, it will ask you any percentage between this line. So there is a mathematics to calculate what is the point here. For example, if pick one point here, this point you project down is 53%. So it will tell you need to calculate how many percent of this portion, how many percent of this portion. The line between the two blue line is called tie line. Okay, the straight line for the fixed temperature is called tie line. Okay. Yes.
What the graph is representing is how much of the nickel and copper
At a certain temperature.
are mixing together.
Yes. Yes, yes. This is like the solubility line, lah. Or you can say solubility line. Lah. So this one you mix if you want to get if you want to get 100% liquid between nickel and copper, 100% liquid, then you can use, as long as your composition is fall within this region and you meet this temperature, you will get liquid form. So if you want to get solid, either between copper and nickel, then you mix all the percentage as long as you within this region, this percentage at temperature below this blue line, you get solid. Okay. So this is to predict the phase transformation in the microstructure. Okay, we enlarge the graph. This is copper nickel system, binary system with the two component there. All right. Okay. This one already explained where is liquid, where is solid, and so on. So nothing. Okay. Again, I highlight the Gibbs rules. This one, y is +1 and not +2 because on this graph you don't see temperature, you didn't see pressure. And when you don't see pressure, the whole experiment conducted at a constant pressure. Okay. So, for example, at melting point of pure component, the number of component is 1. So here is 1, here is 1. Number phrases 2 when you have a liquid or solid. So this is to tell you at the melting temperature, this one or this one, there's no freedom that you can choose. There's only one temperature that it can melt, for example. For pure component. For pure component. So these are just further explanation. In single phase region, this one is single phase. Two phase region. This is just some calculation using the P plus F C plus 2. This one you read lah. I want you to focus on calculation on this line. This one is extra information. This one temperature time, different pure copper. Right hand side will be percentage of nickel and temperature. It's just a graph lah, nothing, just extra information for you. Okay. And the shape of the graph, shape of this blue line will be different from different combination. So don't assume that all the metal will have this ellipse shape. No. So different combination of metal give you different shape phase diagram. Okay, this one also information for you. All the phase diagram, if it's liquid, then you will see capital L. If you see solid, you will see capital S in all the phase diagram. We start to learn second equation for today. So we're only interested in 3 points like this. So on the graph, you will see 3 points, or we call it LOS point. The one on the top is liquid phase. The one at the below is solid phase. Y-axis is temperature, x-axis is WT percentage, weight percentage. So this one is weight percentage, weight fraction of B means the 0 is referred to B, 100% it will be B. 100% because this is weight fraction. Weight fraction, maximum only have one. Fraction is something divided by something. It's a fraction. This is called fraction. Y and X. So in a normal case, you will see percentage like what you see just now. Okay, so what we're interested is the LOS line. This dotted is called tie line. So this point you know is liquid L, because on the top it will be liquid line. This one will be solid line. That's why you see L and S here. So here you will see liquid, here you will see solid. O point is our interest point. This will be the question always ask you. What is, you need to find where is O. You need to label this O on the graph.
So in this relation between the two lines,
Uh,
is it a specific component that's a liquid?
you have liquid and solid.
So each component could exist, can possibly exist in both.
Yes. So we are going to find out how many percent of liquid along this line. Let's say O, at O point, how many percent of liquid, how many percent of solid. So this method is called Leverous. So in the question, in the exam, you need to label, you need to label LOS. O is the question given in the question. So you need to find what is the WO. Okay. So on the graph, you label LOS. Then there's a calculation there. Okay, let X be the alloy composition of the interest, means the question give you X percentage. And the weight fraction of B in A will be WO. Okay. So this is X is the percentage composition of that interest given in the question. For example, let's say this, okay. Let's say I draw on the whiteboard. You'll be given one temperature, fixed temperature, let's say 1000 degrees C. This is L, this is S, this is L plus S or something. So this one, something will give you alpha, beta, gamma. So you label this is L, this is S. You drop down. You will see percentage of liquid. This is percentage of liquid. You drop down, this one a percentage of solid. The question will give you 1 point here. This is the interest point, WO. You need to calculate this one. You need to know how to calculate this one by referring to the previous chapter. You're given X equal to 100 gram of, let's say, copper or something. You need to convert into percentage of this one. Okay. Okay, so let's point number 1, and you draw the tie line, LOS. Then at the temperature, we're given in the question, the temperature will fix. Okay, so you will form a liquid of percentage of LO, percentage of WS. Okay, so you put in all the vertical line, horizontal line on the graph. For this kind of question, you need to start to detach the graph and then attach with the answer solution sheet. Okay. So you have a few parameter you build on the graph. You label LOS. You look at the question. The question will give you one temperature. You use your ruler, draw a vertical line to form the timeline. Go and label on the left, liquid, lower is solid. Draw vertical line, and this one you need to calculate. You need to calculate. So this one is X. You draw, and then label O, LOS. Then label this one is WO, WS, WO. Okay. You don't, if you forget to label this one, also okay. You straight away, you read from the graph. percentage you see on the graph. Okay. Okay, next we start to apply the percentage by using wet balance. So you know that liquid and solid, you plus together, you get 100%. So XL plus XX equal 1 in all the point, right? So, so it's a weight percentage, weight fraction of the liquid and fraction of solid. So you rearrange the equation, XL equal to 1 minus XX. Or another way is you take 100% minus the previous one. As long as you find 1% of liquid, you can find another one. Okay, so we just apply. Let's consider you have 1 gram of alloy and make this weight balance. So gram of B in 2 phases mixture will equal to gram B in liquid plus solid. Because at this line, 1 gram, if you have it will be in 2 states along this line. 1 gram of B, like for example copper. If it fall on this line in this region, your copper will have in liquid and solid form. We don't know how many percent, but now we want to calculate how many gram in liquid, how many gram in solid. But these two you add will be the original copper that you have. Makes sense, huh? Okay. So you take 1 gram, multiply by 1, you'll get percentage of that one. Okay. So this is wet percentage, wet fraction. 1 gram multiplied by 100%. Okay. This is average wet fraction of the B in fresh, this one. So 1 gram multiplied by how many percent of that component in total is 1, multiplied by percentage of WO. WO is here, is the X interest of what you want. B in liquid form means 1 gram multiplied by XL. This is a fraction of L, right? Plus 1 gram multiplied by the solid fraction. Of course, in test, you don't need to write all this. I will show you the more easier one in the next 2 slides. Okay, in short, is this one. WO. WO means this one. It's a mixture of WL and WS. Right? WO equal to WL, liquid weight plus solid weight. So you want to find the how many percent of your liquid weight, you need to find the fraction, right? How many percent multiplied by the weight, liquid weight, plus how many percent of solid multiplied by the solid weight. I will go this one. You read lah. I'll straight away give you the final answer. Okay. You want to find the solid phase. You want to find the solid phase. How many percent of solid in the straight line? Don't confuse by the graph. You focus on the straight line. You have 3 points, right? You don't care what are the line on the this one. You have LOS. What you're interested in is the total length. Mean this one is you take the total length. This is the total length. The total, how many total you have? So you take S minus L or L minus S, doesn't matter, as long as you have the total length. So you see the bottom one is WS minus LW. Why you take S minus W? Because we don't want to get negative number. Because S will always positive more value than the liquid. But the concept is you get the total length. Get the total length. Then if you want to calculate the solid, right? You flip your thinking. Solid is here, right? The question asks you about solid, you calculate this distance, this region. This is the liquid length. You flip your thinking. If the question asks you WS, you take total length and the liquid length is get the ratio already. Once you get WS, let's say you get 45%. What is WL? You take 100% minus WS will be 55%. You don't need if you want to calculate also can. But you know that combination of solid and liquid is 100%. Yes. Is B component. Solid. Solid.
It's only B.
No. It asks you how many percent is in solid. In this one you have liquid solid, right? Don't confuse between A and B. It asks you about phase. Understand? Yes. Yes. It depends on this one solid. It means B lah. It depends on what you want, because this region they are B solid. All this region they are B solid. Understand? But you just see it in a more simpler way. We are more interested to know how many liquid we have, how many solid we have. Yeah. Okay. You can do the same for liquid percentage. You just flip the thinking, find the total length. If you want to find liquid, focus on the length to the solid. Yeah. Although the one that you see on my slide is a bit complicated, but if you understand this, the one that I write on the whiteboard, it should be fine. Then you write WO equal to XL, WL plus XX, WS. Okay. In the test, we are more focused on how you calculate the ratio, the weight ratio for the this one. I'll show you one tutorial question, then you see how you apply. Okay. You can either find either one. Either one, then you take 100% minus either one that you find. Let's say you take solid, you calculate solid. You don't need to calculate liquid anymore. You just take 100% minus the answer you find for solid phase, you get a liquid phase. Or if you want to verify, you're very hardworking also can. You do the same calculation, you still get the same answer. Okay, we'll see tutorial question. The question. So, weight fraction of solid phase in short. Okay, what percentage of solid phase in short? They are ratio weight percent of solid phase. Solid phase, they are ratio of total length and the liquid phase, LO. Means you need to flip your thinking a bit. So if the question asks you solid, you think about liquid, the length liquid to the interest point. If the question asks you weight fraction of the liquid phase, again, find the total length first. The question asks you liquid phase, think about solid. You take OS divided by LS. Okay, nah? Okay. So if you understand this one, we look at one tutorial question. Derive level rules. You should able to derive lah. This one you having temperature A and B. So derive level rules in the case shown. So this is your homework. Is what is actually same as the tutorial. What is the difference between example 1 and the PowerPoint slides? You see the shape change, but the concept still same. The concept still same. Only you need to be careful. Where is your LOS? It's not always L on the left. Important, you derive your timeline, fix the temperature, draw to the right, then identify where is your L, where is your S, then label LOS. Then start to do your calculation. For example, this one. Example 1. If I ask you weight percentage or weight fraction of liquid, can you find? Weight percentage of liquid is what? Total length of the timeline will be LS at the bottom. Weight percentage of liquid, you don't look at liquid, you look at solid, the length of SO. Yeah. Understand? So you write SO. Then you tell the examiner what are the points that you refer on the graph. So SO, how you get SO? You take what? You're not taking LS minus LO because you get negative number. You take WO minus WS. Then the total length, you do not take LS. You take WL minus LS, because if you take WS minus WL, you get negative number. We don't want we don't want negative number. Okay. So this is just your homework lah. Example 1, just to show you, phase diagram not only have one form. There's many forms. Okay. We go for maybe 5 more minutes, then we call it a day. Okay. 2 equations for today. One is P plus F, C plus 2, or C plus 1. Another one is called level rules. Finding the ratio of the tie line. If you understand this one, then you are good. Okay. Again, this is just a check of knowledge, how to find XL and XX. Now we look into more related to your test or final exam. Now the graph is what? Is focused on copper or nickel? The graph is for nickel or copper? Nickel, caption, nickel. So 0 nickel, 100% is nickel. Okay, so this one is you're very familiar with liquid plus alpha, and solid alpha. In the test, you won't see the dot, the dash line. You only see the very raw data. You won't see a dot, a line. So you read the question. Copper nickel alloy contain 47% of copper, 53% of nickel. Basically, you add these two numbers, you get 100%. But it doesn't matter. It's only you need to be careful what the graph represent. The graph represent nickel. So you focus on the nickel percentage. 53% is a useful information. So when you read the question, 53% nickel, go to the graph. Straight away, label where is 53% nickel. You go to the graph, So go and find 53%, for example, this line, 53%. Draw this line, label X. This is the question want you to find. 53%, go and find 53, draw one line, label X or WO. At one temperature, 1300 degrees C. Go to the graph, find 1300 degrees C, draw vertical horizontal line for all the graph. Okay, you draw one line. You will get intersection of two dot here. Or three, you can say 3 point because just now you already draw the X line. So you draw 1300 line, you will see 3 points. Without looking further, you already draw X, you already draw temperature. Next, you know that you are drawing the time line. On time line, you label LOS. Where is the L? Here. Where is your O? Here. S is here. Okay. Okay. Then LOS, if you forget, if you are concerned, you will forget the equation, then you write long. WL equal to what? SO divided by LS. WS equal to something divided by something. If you're afraid you forget, then you write the equation. Then only you go into the question. What is the weight percentage of copper in the liquid and solid phase at this temperature? Then, what is the weight percentage of this alloy is liquid? What is the weight percentage is solid? You know how to differentiate the A and B? A, it asks you what is the weight percentage of copper? Weight percentage of copper. B, what is the weight percentage of this alloy is liquid? So first one is ask you about copper. Second one asks you about the whole system. Okay. All right. Now, when you draw 1300 degrees C, please go and drop vertical line and then write the number you read here. For example, the L, you drop down about 45. You write 45% here. Here, you write S, drop down, is about 58 something. You write 58% here. Okay. So for A, the intersection of 1000 degrees C line will be this one. He asks you what is the weight percentage copper in liquid. So you 1000 degrees, 1300 degrees C. This is solid, this is liquid. So he asks you, liquid is what? This is liquid L. You label already. This is L. Liquid, you drop down. Go and read the number. You drop down is what? 45%, right? The question asks you 45% refer to what? Nickel or copper on the graph? 45% refer to nickel or copper? Nickel, The question asks you what? Copper. So 45% nickel must comply with 55% copper because 100%. Be careful on the question. This one asks you about copper, but the graph gives you nickel. The answer for the first one is 55% copper in liquid form. Understand? So how many percent in solid? Copper. So same, you have LOS. Your S point is what? About 58% nickel. How many percent of copper? 100%? 42. Right lah. So 42 copper. So remember, this is a binary system. The graph gives you one focus point, which is nickel, but the question can ask you another component, which is, in this case, ask you about copper. Yeah, this just to test you whether you understand this graph or not. Okay, the second part, he asks you weight percentage of this alloy is liquid. How many percent is in solid? Again, use label rules. You label LOS already. You have the number here. This one is, we focus on nickel. We focus on nickel. So the first point L here is 45. Your LWO or X point will be 55. S point will be 58. So to find the percentage of alloy is in liquid, so what? You have LOS. In this case, again, LOS. To find the percentage of liquid, find the total length first. The question answers liquid, flip the thinking, find the length of OS. OS divided by total length, you get the percentage or fraction. Right? Fraction multiply 100%, you get percentage. Okay. So you find all these points. Fraction of phase, fraction of solid phase is what? Solid phase is here, this length divided by total length. Solid phase. This is liquid, this is solid. So liquid, the question asks you, you are calculating solid phase, so this length divided by total length. Okay. In your answer, please label what is your WO, WL, WS, WL. Okay, label LOS, then after that, label what is your WL, WO, WS on the graph. Okay, you put in the numbers. Okay, who don't understand 53, 45, 58? Who don't understand how you get this number? Can Once you understand that one, you get one ratio, which is 0.62, but the question asks you which percent. You need to change ratio into percent. Multiply 100. You get 62%. When you have solid in 62, liquid will be 38%. Mean you take 100 minus solid phase. You get liquid phase. Or if you're hardworking, also can. You do the same thing. For the percentage of liquid, you take total length and then take the ratio of the solid side here. This one divided by this total length. Then multiply 100. Read carefully. Sometimes the question asks you give fraction. Sometimes the question give you percent. Ask you about percent. Just careful on this one. Okay, any question? Easy, right? Okay, liquid phase, if you do, you also get 38%. If you answer, you put 100% minus solid phase percent, also correct. Okay, this is just a test. You see whether you're able to understand. This one is in Celsius and this one is in log form, not log form. This is PD versus AG. But again, remember to read the caption first. Don't confuse by the alphabet on the axis. This one silver. Silver is AG lah. AG. So you are given a graph. In this case, you should be able to identify where is liquid, where is solid. In the middle is L plus S. In the middle is L plus S. Okay, so it tells you to find 1200 degrees C and 70% of Ag of silver. So assume percentage of Ag in liquid form is 74% and solid phase is 62%. Calculate percentage of liquid at this one. This is your X or WO. So again, if you don't know how to solve, you just follow the SOP. First, draw where is your X, where is the question target. Right? In this case, 70% of Ag. Go to the graph, find 70%, draw one line up, label X, or at the bottom, you label as WO. Then you look at the temperature, 1200. Go find 1200, draw one line. You have formed your high line already. When you form your tie line, label LOS. Just be careful, it's not always L on the left. You need to read carefully the graph. So in this case, the L is on the right. So you label SOL. Then use the same principle. Find what is missing. Right? He asks you percentage of liquid and solid at this temperature. So same. Find the LOS. I will just enlarge the graph lah. So you'll get 74% and 64%. Then you have the total length. The total length will be 10. The ratio from 70 to 40 is a L, about 4. So 4 divided by 10, 40%. This side is liquid. So 40% is solid, 60% is liquid. But you need to write the calculation by using level rules. Level rules. Okay. So you get 60% for liquid, 40% for solid. The principle always same. The graph will change, but if you follow, draw the X line, label WO, follow the temperature, draw, you will form LOS. Then depend on what question asks you. Right? Okay. Okay, so if you understand this one, then I think we stop here lah. The rest is non-equilibrium. All right. This extra information. I don't ask you on the non-equilibrium things. Non-equilibrium means you cool down the temperature, the metal in extremely slow. You slowly cool down. So when you slowly cool down, they have a time for them to rearrange themselves, right? Okay, so this one I think is another topic lah. This one will be in your final. Test 2, I won't ask you this one. I'll ask you in final. All right. Okay. We continue this one in next class. So your replacement class is as what I write on the whiteboard here.